In this video, I'm going to discuss a new strategy for showing disjunctions and then fit that into our more general derivation setup strategies. So let's talk about showing disjunctions and derivations. So the old way, if we wanted to get, if we had a show line that was P or Q, what would we do? Well, somehow or other we would get P, who knows how, and then we would apply addition and we'd get P or Q. Or maybe instead we get Q somehow, and then we'd then again create P or Q with ADD. And in either case, we could then do a direct derivation. This strategy is fine as far as it goes, but it doesn't always work, because it's not always the case that without doing anything fancy, you can either get to P. Can you get P? Not necessarily. Can you get Q? Not necessarily. So you have to. This strategy doesn't always work. There are a couple of more general strategies that will work. The most straightforward one is to use a derived rule called De Morgan's. So if you haven't watched the video on derived rules and you don't know what those are yet, then you should watch that now and then come back, because what I'm going to do right now is show you how you would apply this derived rule, De Morgan's. So De Morgan's is a derived rule. It's abbreviated by DM, and so what you really need to remember is DM. It's named after the person De Morgan who first explicitly noticed these relationships. The relationships, just like we go all the way back to Chapter 1 talking about modus ponens, or Chapter 3 talking about modus ponens, we recognize these relationships when we see them. De Morgan was the first to reflect on them and write them down. So we have the left column and the right column, and these are basically the equivalences that I talked about in the negation, conjunction, and disjunction in the formal language video, but here we have them as inference rules. So derivation 266 is a theorem, and it enables the left column, the left two rules, and derivation 265 is another theorem, and when you complete it, you enable the two rules on the right. And what they basically say altogether is that if you have a negation of a conjunction or a disjunction, you can change it into a conjunction or disjunction of negations. So it says when you have a V or an OR, when you move the negation across it, you flip it. And that's what all four of these together say, is when you have when you move the negation back and forth across the operator, from you have the negation of the operator and you put the negation on the inside on the pieces, then you flip the negation sign. This is kind of like when you have the distribution of a minus in arithmetic. You have negative 5 plus 6, so you can move the negation inside, and you get negative 5 plus negative 6 is the same thing, for example. Or if you have a negation of multiplication. So the important version is the most important version is the top left version that says if you have the negation of a disjunction, you can turn that into a conjunction of negations. And that's important because we use it in our strategy for showing disjunctions, and that's what I'm going to show you now and show you what it looks like in the derivation module. So let's suppose that we were trying to show a disjunction. It doesn't matter what. We're not going to do a whole derivation. We're just going to look at the setup. So let's say we said, okay, I'm going to show P or Q, and there's some premises, whatever the premises may be. Well, at this point, we should always be making an assumption. And we can't do assume CD, so we do assume ID. So we have negation of P or Q. Now, what are you going to do with that? With our basic rules, nothing, right? Because we don't have anything with our basic rules that applies to that. But there's this rule DM that says, oh, look, you can turn that into a conjunction of negations. And we have rules that work. Now, 3 is a conjunction, right? 2 is a negation. 3 is a conjunction. And conjunctions are really powerful. We can do a lot with conjunctions because we can apply simplification. We can apply simplification twice. And whenever we have a conjunction, we want to make sure to apply simplification twice so we don't forget about one of the two pieces. Maybe we need them both, maybe we don't. But if we don't know, we definitely want to apply simplification twice. And then we have negation P and we have negation Q. And then we can go ahead with our derivation and do the rest of the, so then we bring in our premises and we look for a contradiction. And eventually we get one, and then we'd say, I don't know, 9, 10, whatever it is, ID. Okay, so the key thing is here. these steps, okay? When you're trying to show it, when you have a disjunction, then you say, okay, good, I'm going to make an indirect assumption, but then I'm immediately going to apply my De Morgan's rule. And that's going to my new De Morgan's rule once I've done the theorem that turns it on, and then I have this conjunction, and I can use the conjunction, I can apply simplification to it. So, but to do this strategy, right, you need to enable the DM version that applies to 2, and that's done by doing theorem, problem 266. And guess what? Lucky for you, while it's a very difficult derivation, I'm going to do it in another video. So you need to do that derivation in order to turn DM on, but you can, and you can do it very easily. You can do it very easily by following along with me in that other video. Right now, what I want to do is just quickly then review all of our different derivation setup strategies. So I'm going to go back to the slides and finish off this video by looking at all our different strategies. So here on this sheet, on this page, on this slide, we have all of our sort of basic derivation strategies. So in the top left, we have, okay, if you have a conditional, show if P then Q, what do? You assume CD, and then probably you try to get Q for CD. Not necessarily, because maybe you'll get P or Q for DD, or maybe you'll get a contradiction somewhere for ID. We've already seen how you can do that sometimes, but in general, probably you want to get Q for CD. The bigger ones on the right, so we have if you're trying to show a biconditional, you show both of the conditionals and put them back together using CB and then apply DD. If you're trying to show a conjunction, the most general strategy is you do a derivation of the one P, and then you do the subderivation of Q, and then you put them back together. And then in the bottom left, we have this new strategy we just learned about for disjunctions, where you make this indirect assumption of the negation of P or Q. You apply De Morgan's to move the negations in, and then you split up the conjunction with the simplifications, and then you try to get a contradiction. And if you're trying to show P or you're trying to show a negation, then you would make an indirect assumption. So there are our basic derivation strategies. So all the slides from this video are below in a PowerPoint, but then also there's a PDF of just this last slide that you might find really helpful to have printed out and handy when you're working on derivations.